All right, ladies and gentlemen, we have talked about three laws already. Boyle's law. Let me throw this marker away. Boyle's law. P1 V1 equals P2 V2. Okay, and that's the relationship between pressure and volume. When pressure goes up, volume goes down. Okay, this is an inverse relationship because they go opposite direction. One up, the other down. One down, the other up. Doesn't matter. Okay, they're always opposite. And then Charles' law talks about temperature and volume. V1 T1 equals V2 T2. And temperature goes up, volume also goes up. All right, this is a direct relationship. Because if you have a graph, it goes like that. And Boyle's law, if you have a graph, it goes like this, downward. Okay. And then there's one more that is not mentioned very often, is Gay-Lussac's law. It's between pressure and volume. P1 over T1 equals P2 over V2. So, over T2. So same thing here. It's a direct relationship. As temperature increase, pressure will also increase. Temperature increase, pressure increase. Because again, remember, temperature does what? Temperature makes these molecules move faster. So if they move faster, they bump into the walls more often, creating more force against the wall, therefore higher pressure. So they just keep bouncing off these walls. So temperature goes up, pressure goes up. Okay? All right. And so today what we'll talk about is something called a combined gas law. What do you think that means? That means we combine all three of these. Okay? So in other words, it's P1 V1 over T1 equals P2 V2 over T2. This just means that now if you change one variable, the other two will change as well. And that's in reality, that's what happens. If temperature goes up, what happens is pressure and volume goes up. Okay? If temperature stays the same though, we have Boyle's law here, then pressure goes up, volume goes down. Okay? So if we can cover one variable, volume, then we have Charles' law. We cover pressure, then we have Charles' law. What did I say? Boyle? Yeah, we cover V, you have Boyle's, Charles. No, Boyle's is this, cover T. Never mind. Boyle's you cover T, there's no T. Boyle's, Charles, and Gay-Lussac. There you go. So all three laws in there. Okay? And you see this very often here. Sometimes they say this and this and this and something is constant. Okay? This constant tells you it does not change. So when it's constant, you can pick any number. For example, when say pressure is constant, that means pressure could be, just put 1. I would just put 1 because that's the easiest thing to work with. Or if it's constant, just cross it out. We don't deal with that. All we have left is P, V over T, V over T. Whichever is constant, you can cross out. You can cross out that variable because it cancels each other out. When it's constant, it cancels each other out. Okay? Alright, so how does this work here? You have problems like this, then you have now 6 variables. 2 V's, 2 P's, and 2 T's. Okay? A lot of numbers here, but it's not complicated. You list P1, V1, T1. P2, V2, T2. Again, temperature must be in Kelvin. Right there. Okay? Everything else, pressure just needs to be the same unit pressure. Volume needs to be the same unit volume for both of them. But temperature has to be in Kelvin. Alright, if a 22 liter of nitrogen, so this is, let's say this is V1, pressure P1, and then it's compressed to that, so this is to that, so this is P2, at constant temperature. Ooh, look at that one. Nice. Constant temperature, so we don't need that temperature. Okay, we cross that out. What is the new volume? So in other words, P2, that's what we're looking for. Hey, we can do this instead of listing it. That's perfectly fine. If you want to label it like what I did up here, that's perfectly fine. Okay? I'm not going to stress too much on that. So I'm going to write it again though. 748 millimeter of Hg. 22.5 liters. P2 is 725 millimeter of Hg. And V2 is X. Okay, that's what we're looking for. So all this is that equation. P1 V1 equals P2 V2. Notice, remember, I just want to write the whole equation again. That's the equation. So T is constant. We cross T out. Well, it should have been T1, but we cross T out, and what do we have left? All we have left is Boyle's law. Plug those numbers in and get the missing variable, which is V2. So P1, which is 748, times V1, which is 22.5, equals P2, which is 725, times X is our V2. Okay? What do I do with that to get my X? I divide both sides by whatever's with X. 725. 725. I divide that and I will get my handy dandy answer. My calculator. Here it is. 748 times 22.5 divided by 725. And my new volume, V2, is equal to 23.2 liters. And that is beautiful. 23.2 liters. Okay. Let me look for one that has all the variables. Here it is. Look at number 3. Number tres here. A gas takes up a volume of 15 liters. So this is V1. This is P1. And this is T1. Okay, it's Kelvin. ATM is the pressure. So recognize them by their units. Okay, liters is a volume. If I raise the temperature to T2 and the pressure is now P2, uh-oh, there's a problem here. We have one is ATM, one is millimeter of Hg. So they both need to be the same. I like to work with smaller numbers, so I'll change it to ATM. So I'm going to go ahead and list these out. 15 liters. P1 is 3.3 ATM. I just like this organized in a way that I can keep track of all my numbers. Because now, since we have to change things, V2, what will be the new volume? So we're looking for that. That's our X. P2 is 1050 mmHg, and T2 is equal to 350. Okay. So this one, we need to change the atmosphere. So I'm going to go ahead and change it. 760 of that is 1 ATM. Okay. So 1050. Come on. 1050 divided by 760. That'll give me 1.382. As I work, don't round this number too much. Okay, maybe keep 3 or 4 decimal places, because if you round it too early on, it'll throw your answer completely off. So within your work, don't round too much. Your answer you can round. Well, let's plug that in. V1, which is 15, times P1, which is 3.3, over T1, which is 299, equals V2 X times T2, which is 350, times over, that's not T2. Where's my handy dandy whiteout? It's supposed to be P up here. P2, which is 1.382. Hope you can see that. Yeah, 1.382 there, over 350. Okay, this is a lot of numbers. Okay, so keep track of them. Cross multiply. And so I'm going to do that in my calculator here. So 15 times 3.3 times 350. I get that number. Okay. I'll go ahead and divide it by 299. And then I can divide. So this is 57.9 something, yada, 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 yada. So I end up with 57.943 equals X times 1.382. How do I get X? Now I divide both sides by 1.382, and I'll get X is equal to 41.9 liters. Right, the first one's liters, so this is my V2. That's volume 2. Okay? So yes, there's a lot of numbers here. You can go ahead and solve that one. How you do this is up to you. you can go and solve that one, get one number, and then multiply by 350 and divide by whatever's with the x. So moving all these variables around could be a little confusing. So figure out a way that works best for you. Alright, some people, they like to move the variables around first. For example, like this. If you'd like to do this, go for it. P1, V1, T1 equals P2, V2, T2. Alright. Maybe in other classes, maybe Miss Carrasco's class or Miss Coronado's class, they do this. They cross multiply first like that. So it's P1, V1, T2 equals P2, V2, T1. That's to get rid of the fraction. So this equation could also be used if you like this equation better. Okay, it's P1, V1, T2. And this is all multiplication. Okay, times. So when you plug it in, it is actually easier to manipulate. So if you want to use it like that, that's perfectly fine. Okay, so complete this worksheet here, 1 through 11, all 1 through 11. Again, it is a lot of practice. It is a lot of work. So, but it gets you better when you practice a lot, right? All right, goodbye. That's it. I should have the answers somewhere. I'll post it on just the answer, okay?